Hey guys, welcome back. This is chemistry with Miss Gray, and we're going to work on molar mass today. Molar mass is one of the easiest things that we're going to learn, so hang on, this is going to be fun. So molar mass is something that we're going to need a periodic table for. I have one here in our slides, but if you get yours, you'll be a lot happier. So for the molar mass, we're going to use the periodic table. The mass of 1 mole of any substance is called its molar mass. That's pretty simple, right? And here's an example where you'll find the molar mass. For 1 mole of lithium, find lithium on the periodic table. See this number here? That's the atomic mass. Hey, that's it. That's the molar mass of lithium. 1 mole of lithium will have a mass of 6.94 grams. That's all there is to it. That wasn't so bad, huh? All right, well, surely there's got to be more, right? Well, not really. We're going to always write the units for molar mass as G/mol for grams per mole. And here's what we're going to do with it. So we're going to use the periodic table to determine the molar masses of these substances here. So for sulfur, we're just going to find sulfur, here it is, and read the number from the periodic table, and that's its molar mass. Sulfur has a molar mass of 32.07 grams per mole. That's it. That's all we do. I know. So then the next one, though, asks the molar mass of SO2, sulfur dioxide. So we're going to have to take sulfur, which was 32.07. We're going to add it to the mass of 2 oxygens. So for oxygen, there's 2 of them, and its molar mass, let's see, is 16.0. All right, so that's 32 and 32 is 64.07 grams per mole for SO2. That's it. So we just take the molar mass of each thing that it says in the formula and we add them up. All right, so now I've got a hard one. Copper 2 borate is our next substance. So that means we have to add more stuff, right? So I have 3 coppers. So find copper. Here we go. 63.55. Okay, we're going to add that to the mass of 2 borons. All right, where's boron? Here it is, 10.81. So 2 times 10.81. Okay, and then how many oxygens? 3 times 2 is 6 oxygens. So 6 times 16 oxygens. All right, well now this isn't math that I'm willing to do in my head. I don't know about you, but I'm going to use my calculator for this one. So I get 3 times 63.55 is 190.65. So 190.65 for the copper section. Now let's do the boron. 2 times 10.81. What do we get there? 21 point. Oh yeah, I could have done that in my head. 21.62. Okay, and then 6 oxygens is 6 times 16. 96. Okay, so that's the part that's coming from oxygen. So now we just find the sum of these 3 values. All right, so 96 plus 21.62 plus 190.65. And I really need you guys to follow along with your calculator and check my work. It is possible for me to make a mistake or for me to push the wrong number on my calculator. So if you catch one of those mistakes, I need you to tell me before everybody listens to this podcast and finds my mistakes too. So I want to show you how to do it the right way. If you catch a mistake, please let me know. So I got 308.27 grams per mole for the copper 2 borate. That's a pretty big molar mass, especially compared to that lithium that was only like 7 grams per mole. So that's how I do molar mass. Use your periodic table, add them up, and that's it. Really, that's all. So this should be a short podcast, right? Except that we have to practice. You know what? I'm going to let you guys do these ones. I'm going to let you take care of this. So we have calcium chloride, ammonium carbonate, oxygen, lead 2 phosphate, and then C6H12O6 is glucose, right? From photosynthesis, that's that same stuff. I want you to do the molar masses to 2 decimal places for all of these 5 substances. I know you can do it. I'm going to do some harder ones. Now, there's other names for molar mass, so I don't want you to be fooled if your book uses some other terminology. First of all, gram atomic mass, GAM, is the molar mass of an element where all the atoms in the substance are the same kind of atoms. So they may use the term, instead of molar mass, they may say the gram atomic mass. Don't be fooled. It just is the same as molar mass. Use your periodic table and you'll figure it out. Okay, the gram molecular mass means the molar mass of a molecular compound where the atoms are covalently bonded to one another. That's all that is. Okay, and then there's one more, the gram formula mass. In an ionic compound, we have simple mole ratios, right? Where it doesn't exist actually in a molecule, but more as a ratio of atoms in a crystal network. So the gram formula mass is the molar mass of an ionic compound where it has a metal and a nonmetal in the same compound. So these are the 3 different ways of saying molar mass. And now you won't be tricked and you won't be confused because I warned you, right? So suppose that we want to convert between grams and moles. If you're given a number of grams of a compound, you can determine the number of moles and vice versa. So to convert from one to another, we have to know its molar mass. And then we'll use the t-table to decide whether we're going to put grams on top or grams on the bottom. Notice 1 mole is always going to be the same. 1 mole. That's the easiest way to do it. So let's practice this. Right, in HCl, then we have hydrogen and chlorine, and I need that periodic table back. How could I get to my periodic table? I know you guys have a periodic table all ready to go, right? Okay, so I need hydrogen and chlorine. Hydrogen is 1.008, and then chlorine way down here is 35.45. All right, now back to the problem. Okay, so first we need the molar mass right here. If hydrogen is 1.01 and chlorine is 35.45, then we don't need a calculator, just add those together, 36.46 grams per mole for HCl. We know we've got 0.25 moles, and so I want to use a blank screen here. All right, so if I'm starting with 0.25 moles of HCl, and each mole, for every 1 mole, is going to weigh 36.46 grams. Then how many grams is that altogether? So notice in my t-table, I put moles on the bottom because crisscross cancels. And so I need my calculator to do 0.25 times 36.46. And 0.25 is the same as 1/4, right? So when I multiply 1/4 times 36, I should get something close to 9. So if I don't get that, then I'm doing it wrong. Yep, I did it wrong. Clear. Okay, 0.25 times 36.4, 9.1. Hey, that's more like it. I don't know what I did the first time. 9.1. Go back. There we go. 9.1 grams of HCl. Okay, so now that's going to have to go into our little table thingy. Practice problems. Okay, 9.1 grams for every mole of, for every 0.25 moles of HCl. All right, the next one is H2SO4. You should recognize this chemical formula as sulfuric acid. So this time I'm given the mass and I need to calculate moles. The only way to do that is to use the molar mass. So let's add this up. Hydrogen was 1.01, and then what's the mass of sulfur? Do you remember? 32.07, and then I have 4 oxygens, so 4 times 16. We're going to add this all up. And I'm not going to need a calculator. 4 times 16 is 64. 64 plus 32 is 96. Add one more for the hydrogen, 97, okay, 0.08 grams per mole. So if we have 97.08 per mole and there's only 53 grams of stuff, then I don't have one whole mole. I have something that's less than 1 mole, right? Well, let's get our blank screen and we'll do the math that it takes to figure this out. Oh dear. I forgot what number that was. 53.15. So our problem starts with 53.15 grams of sulfuric acid. And I know that for every 97.08 grams, I have 1 mole, right? So grams I put across from one another so that I can cancel them out. So I'm going to do in my calculator 53.15 times 1 divided by 97.08. We multiply across the top and divide by what we have on the bottom. So 53.15 divided by 97.08. 0.5478748, blah blah blah, lots of calculator vomit. I'm only going to keep 4 sig figs, so 1, 2, 3, 4. After the 4, the 8 tells us to round up. So let's call that 0.5475 moles. Of sulfuric acid. We said it should be less than 1 mole, right? And it's almost half, because 50 is almost half of 97. Okay, so back to our little table, 0.5475. Okay, so we put that in our table, and we're on to the next row. Now we're given the number of moles of sodium chloride, NaCl, and we need to figure out the mass of sodium chloride. So we need our periodic table to find out how many grams per mole is sodium and how many grams per mole is chlorine. All right, sodium's down here, 22.99, so we could call that 23, right? I'm not going to round yet, but pretty close to 23. And then chlorine is 35.45. So let's go back to our problem and solve for the molar mass. So I have 22.99 plus 35.45. Okay, so now add these numbers together. You can do it. 58.44 is the molar mass of sodium chloride. Now we use the molar mass to figure out how many grams of sodium chloride are in 3.55 moles. Great, so let's use a t-table. We had 3.55 moles of sodium chloride. And for every 1 mole, we had how much? 58.44 grams of sodium chloride. And so I put moles on the bottom because if I start with moles on top, that's the only way to get it to cancel. Crisscross, right? And so now we're going to multiply these together. 3.55 times 58.44. I get 207.462 grams of sodium chloride, and I get to keep only 3 sig figs. 1, 2, 3. So I don't need any of that. Just the 207 grams of NaCl. That's all there is to it. Using the T-table. That's pretty nifty, isn't it? I know you were afraid of T-tables because it seemed really hard before, but it's not that bad, I promise. So we had 207 grams and 3.55 moles of sodium chloride. Our last one is just asking about copper. Copper is an element made entirely of one kind of atom, so its molar mass we can read directly from the periodic table. I don't have to add anything up. So 63.55 grams per mole of copper, and we have 1.27 grams of copper. So how many moles is that? 1.27 grams. It's way less than 1 mole, right? Because 1 mole has 63.55 grams in it, and we only have 1.27 grams. So I'm going to set up my T-table so that grams is on the bottom, crisscross, to cancel it out. And now I need my calculator. 1.27 divided by 63.55. 1.27 divided by 63.55. And I get something less than a mole, just like I said. So that is 0.01998. Let me see. How many sig figs? I get to keep 3 sig figs. So after this number, I need to look and see what's going to happen. I'd have to round up, huh? Okay, so if I round this up to, oh, then that rounds this up. Oh boy, so I get 0.0200 moles of copper. That rounding thing, good grief. Good thing we checked our sig figs, or we would have gotten it wrong. So 0.0200 moles. Let's get that written into our table. Oh, I put it in the right spot. Oh, that was good. Yay. So that's how we do these molar mass problems. We've got a few more practice problems to work through, but I'm going to save those for class time. We'll do these in warm-ups and stuff, okay? So how many moles and grams? You just need the molar mass. Let's do the first one, and then I'll let you guys handle the rest on your own. Okay, so how many moles are represented by 16 grams of ethanol? So our first job is to find the molar mass, right? So the molar mass of ethanol, we're going to need 2 carbons. So 2 times 12.01 grams. Get your periodic table so you can follow me. Now look how many hydrogens there are. I have 5 here and then 1 more here. So 6 hydrogens altogether. 6 times 1.01 grams for hydrogen. And then oxygen has only 1, so 1 times 16. So let's add these up. So I get 24.02, 6.06, and then 16. So add them up. 6, carry the 1, 46.08 grams per mole. So that's the molar mass, but I have not yet answered the question. This is only a technique to get to the answer. So I 16.0 grams of ethanol. I'm going to call that ETOH. Okay, I have 16 grams of ethanol, and I want to put grams on the bottom. So I know there's 46.08 grams of ethanol in every 1 mole of ethanol. So now I'm going to do the math. 16 divided by 46 should be somewhere around 1/3, because 16 goes into 48 3 times. So 16 divided by 46.08 gives us 0.347. 0.347. The 2 is not going to make us round up. Yeah? So I canceled out my grams. That means I got to moles, and I answered the question. Moles of ethanol is 0.347. Put a box around your answer because that's the way I like it. So we'll save the rest of these practice problems for in class. And if you work them all out, all on your own, show your teacher so that we know you've got this and we can check it off on your progress.